Hello, GM everyone. We are back for day 10, and today the video will be very theoretical and we'll not be writing any code today. But what I have planned is from day 10 to day 15, we'll make a full-fledged project which is building a DEX, which is decentralized exchange. Throughout these 10 days, I have been writing contracts, I have been writing minimal front ends for you, but I have not written an end-to-end DApp for you. So DApp, that stands for decentralized app. Okay, I have not built this. There are a lot of components that we have to manage in this thing, which I want to demonstrate to you of how it is done. So what we'll be building is we'll be building a decentralized exchange. Before going into this, I would like to just mention a great image that I came across on Twitter today. So this is basically how a smart contract works if you have to make it easy for it. So I'll just run through the diagram. You can get into the details later. So the smart contract is compiled with three analyses that we have all know: the semantic, lexical, and syntax. And then it is compiled into the bytecode. Bytecode is the machine language. Okay. Then it is broadcasted to ETH network and added to mempool. Now, what is a mempool is where all the transactions are stored or placed in a queue before they go into the execution phase. Now there is an Ethereum client, which is like a validator node. So basically someone who's running a Ethereum node. So they pick up transaction and they all run all these checks. And if those checks fails, it returns. And if it is not failing, that is it's successful, it returns a runtime bytecode. And in that validator's local environment, this bytecode runs, and then there is a block template, which is transaction, state root, and metadata. Metadata consists of who has done the transaction, who has been the client of this transaction, and stuff. So a block template is sent to the consensus client. Consensus is basically who agrees to that this is valid or this isn't valid, whatever. And then the consensus client goes back here, and then there is a consensus layer. So this is the complex architecture of how actually the smart contracts are compiled, deployed, executed, right? So there are three layers I can see here. There is a validator node, there is an Ethereum client, and there is a consensus client. Credits to OX Gojo Arc for this great image. I'll link the image here in my YouTube video description. So yeah, coming back to what we're building, we are building a DEX. Now let's start with what is a DEX. What is an exchange first? Okay, so an exchange. Okay, let's go here. Let's go. What is an exchange? So as the name suggests, it lets you exchange or swap one asset for other. Okay, one asset for other. So a great example of a decentralized exchange would be Uniswap. Uniswap. This is something what a decentralized exchange looks like. Oh, let's not go here. It is Uniswap. Okay. Uniswap. Okay, let's see Uniswap. Okay. So this is something that exchange looks like. Then there are pools here, which we created yesterday. So let's see, explore the pools and tokens. So here we can see token pairs. Oh, these are just individual tokens: Ethereum USD, Tether USD, Ethereum, deployed on base basically. Then there are pools. So there is WBTC, USDC, USDC ETH, different type of token pairs here. And then there are transactions that are going through. Let's click on any pool that we might make here. Yeah, this is a pool. Now these blocks that you see is the liquidity and the fees in that range. I'll explain it as we are building through these. Now there is a swap button here where we can sell USDC and get ETH, or because it's a USDC ETH pool, it's not an ETH USDC pool. Okay, so there is a limit order also, there is a send, there is a buy, So I'll explain everything when we are doing it. There is something called APR. APR refers to how much interest you are getting if you are providing liquidity to this. Now, what is providing liquidity? We'll get into that. Okay. Now, this is something called DEX. Okay, this is not a centralized exchange. Now, the difference between DEX and CEX is we are going to use, but let's see a centralized exchange here. So this is an example of a centralized exchange. Let's go to orders, and it's just a dummy account that I have here. So let's go to spot trading, and this is something, I mean, the interface changes, but this is something that is Binance is a centralized exchange. Okay. Now, what is the difference between both of these, right? So since we have covered this, let me get this here. And since we have not covered this, let's keep it in here. Okay. It's okay here. And let's keep this here and here. Okay. Is that cool? Yeah, it is cool. Okay. So DEX and CEX, that is centralized exchanges. Now, what are the differences? So basically, there is something that in Web3 which is called custody. So there are many protocols that will tell you that this is a custodial wallet, for example. This is a controllable wallet or not controllable wallet. So in centralized exchanges, the exchange holds your money or money. Okay. But let's just tell this. Yeah. The exchange holds your money, while in the case of decentralized exchanges, you are controlling your wallet. Okay, so these are the first differences, that is based on custody. I'll write the categories that we're going through. Then there is order matching. Now in case of DEX, what we did yesterday was automatic market makers. So this is something that is in DEX, but in centralized exchanges, there is a concept of an order book. Now, what does an order book look like? This here is called the order book, where you see. Oh, let me just make it here. Yeah. So the red orders are of sell and green are of buy. There is bid and ask. Bid is when you are want to buying the token, and this ask is when you are selling it. So you're asking for a price of something. Okay. So there is order book in here. So they need to match your orders. So let's say you are here and you want to sell Ethereum for 100 USDC. Okay. So this is an ask. So your asking price is ask. So this will be converted into 1 ETH per 100 USDC. Okay. This is something that we can see here, whatever. And then there is someone who wants to buy Ethereum for 100 USDC. Okay, so the bid will be 100 USDC for 1 ETH. So that is here 1 ETH. Okay, this is the algorithm here, and then these two orders get matched. So both of them have a matching here. I want to see if we can have a multi-headed arrow, but no, that's okay. That's okay. Yeah, cool. So this is something that is done in case of centralized exchanges. Okay. Now there are some normal terms like they require a KYC, whatever. These are completely on chain. I'll say matching order, matching category, and this is identity. Okay, so now the one thing that I can see as a flaw in DEX is there is something called slippage. I'll explain slippage when we are writing the pools very well. This is something called, let's say, flaws, and these are, I'll say, you have to trust them. So you have to trust a centralized exchange like Binance to not run away with your money. So yeah, that's that. And there is a great article here by Britannica Money, and we can get everything in here. So there is transaction speeds are fast in centralized exchanges because they are controlled and using a centralized mechanism, whereas DEX relies on blockchain for every transaction that is happening here. Okay, so custody of your fund, not your keys, not your coins. This is a great article. I'll link this to the video. Okay, this is a good table that we can have here. I don't know if I can copy this. Okay, I'm not sure. Yeah, so okay, since we have understood this, now let's go to what are the key components for a DEX. Let's bring this frame a little big so everything is in one frame. Okay, so let's get back here and let's see. Okay, so what are the key components of a DEX? Okay, let's write it down here. Key components of a DEX. Okay, so the first key component that I see here is automated market makers. Okay, makers. Okay, now automated market makers actually have different type of formulas and pricing mechanisms they can have here, but let's consider the formula that we had yesterday, which was okay, x into y is equal to k. That's cool. Yeah. And then on the other hand, there is something called token pools. So token pools, okay, so that are like two token, let's say ERC20 pairs in one smart contract. Okay, that's okay. And then we have swaps. Okay, then there is swap, or there is swaps, that is token A is completely interactable by swappable by token B on whatever rate that is going on. Now on the fourth term we have something called LP tokens, which we did not cover yesterday. LP tokens represent the share of your liquidity in pool. Okay, so when these pools are made, let's say I'm creating an ETH USDC pool. Okay, so now whenever someone wants to deposit a lot of ETH here, let's say I have 100 ETH. Okay, I wish I had that. I have 100 ETH and I want to deposit into this ETH USDC pool. So that is called providing liquidity, right? Providing liquidity. So this is done, and on behalf of that, the smart contracts mint some token to this, let's say A. Okay, let's make it capital. He's got money, so the A should be capital. And this contract gives back some tokens here, which are called LP tokens. Now LP is what it's called, liquidity provider. So let's assume a scenario where a pool is made but there is no real money flowing into this, right? So that would refer to this pool having no liquidity at all. And as we have discussed, how do tokens get their value? They get their value using two things, the rarity and the liquidity, right? Yep. Okay, we are back here. Okay, so this guy gets some like LP tokens, which represents how much liquidity has he or she provided. Represents how much liquidity have they provided. They provided. Okay, that makes sense. And when they want to withdraw their money back, so let's say they want to withdraw those 100 ETH, so they'll withdraw 100 ETH, and either they can get their token as an ERC20, that is USDC or something, or they can get native ETH for whatever worth of 100 ETH was. So let's say 100 ETH was worth $10,000. Let's keep it simple. Okay, let's keep it simple. Now they will get ETH, whatever ETH is worth get ETH worth $10,000. Okay. Same goes for the people who are providing dollars in this pool, that is USDC. So wherever I mentioned dollars, just consider it to be USDC. Okay. So that is that. Now, decentralized exchanges also let people create their pools. So let people create their pools. Okay. This is something that is also allowed in DEXes if you have the money and if you have the liquidity. So now that's okay. We have covered the key components here. Now, how will we build this Mini-DEX? Okay. Let's get back here and let's separate this. How do we get a separator here? I think this line will be enough. Yeah, I hope this is straight. It is. Yeah. Wow. Nice. Okay. So let's get here, and now our approach to building this. Okay. So how can I see it as a high level approach? Okay. So we have three primary divisions of any DApp. So there is a smart contract part of it, there is a front end part of it, and there is a backend part of it. Okay. Yeah, oh, smart contracts do have a backend because how will users interact? They won't be sending a transaction every time, right? They need to hit an endpoint. So on the smart contracts part, it says smart contract part. Okay. Let's just write smart contracts. And then we have the backend, and then we have the front end. Okay. Front end. That's it. And these three will be making a tab that we are wanting to create. Let's make the tab first. Tab. Let's keep it a little big. And these three will make the tab. Okay. And boom, 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 boom. Okay, that's the architecture for now. Now let's write what type of contracts do we need to write. So the first will be token contracts. Okay, basically we'll just mint some token pairs. Okay, token pairs, whatever. Then we need to write the LP token logic. LP token logic. We need to also decide if this will be uniform across all pools or different tokens for different pools. Okay, and the third topic would be basically making the liquidity pool for liquidity pool. Okay, and then we'll have two factory contracts here, that is DEX factory and the router. This is not actually a factory contract router, but this will be the external interface. So router is external interface for users. Okay, that's cool. This is something that we are trying to build in smart contracts. Now on the backend part of things, we will start with having let's see, what would the backend have. So now the backend needs to have an endpoint where we fetch pools, we let users do we need to create an account? No, we don't need to create an account. Get their positions, and for now let's keep it as get their profit, PNL, basically PNL, profit and loss. Okay. And the front end part. So for the front end part, we need a minimal interface. I'll not make it very fancy, but still better than what we built in these 10 days. Then there will be a token faucet. Basically, we'll not let users buy those tokens because the tokens that we'll have would be like dummy tokens, so they can claim tokens from a token faucet. Then there will be add, remove, liquidity. Then there will be a create pool, and then there will be a swap and pool. Yeah, I think we should maintain the pools here. Maintain pools created. by users. I think I would want that to have a database entry somewhere. Okay. Now, when we go back here and see if we have done everything that we need, let me see. Yeah, I think we have done everything. Okay. Yeah, cool, 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 cool. So this will be a hands-on approach on building this. There are a lot of things that we need to define here. Let's define those terms. Okay. There is slippage in uh pools and liquidity pools. Let's start with that. Okay. So what slippage means is that for let's take an example. Okay, let's take an example. So there is this pool. There is this pool where ETH currently one ETH is equal to $100. Okay, and after some interaction, someone puts some money here when ETH is puts money. Okay, when ETH is worth $100. Okay, now here the ETH gets whatever, and then after a while, so I'll need to write it after a while. After a while, ETH is priced at, so let's say one ETH is priced at $150. Okay, but out of this, let's say there is some other pool, or let's say ETH naturally grows to that price. So now in real world the value of ETH is $160. Okay. Oh, this is, I think this is I permanent loss. This is not slippage. This is I permanent loss in liquidity pools. Yeah, this is something that is that. Okay. So yeah, I'm just gonna go through this. So 160, and the guy when he's withdrawing, it's 150. Okay. So this is called something as I permanent loss. This is I permanent loss. This is means this loss is not permanent. The ETH can grow here to get to 170 also. But if he had not put some money here, this is basically very cool Schrodinger side of Web3, that unless and until this money is withdrawn, they'll not know if there is a loss or not. Okay. So the value grow to 160, and when he removes the money, he'll get ETH that is worth only $150. And if he had not put the money, he'll have gained $60. But when he put money, he lost it. Okay. So that's something called I permanent loss. We go to the slippage. Slippage is when there is no available counterparty. Okay. So let's understand slippage in the most simple terms here. Slippage is when the quoted price of an asset changes when a trade is executed, resulting in trader receiving less or more tokens as a result. So let's say when I put an order, okay, I put an order of $100 worth of ETH. Okay, worth of ETH. Okay, so this would be let's say for $100 I am getting one ETH. Okay, one ETH per $100. Okay. Now, if the price of ETH shoots up when the order is placed to, let's say, 0.80 ETH per $100. So I placed it for getting one ETH, but instead I'll get only 0.80 ETH. So that is something that is called slippage loss. There are a lot of terms here. There is an arbitrage which can be done here, and there is an avoiding slippage. So many protocols, even Uniswap, provides slippage protection. So they give you the least amount of money that you can expect. So I'm not some put some money here, but I can get it. Yeah, whatever. So that's it. So for this video, I think we have understood all the theoretical parts, and the next 5 days we'll be building this project from scratch to smart contracts, backend and front end. Thank you for watching.